Hey everyone, welcome to the live stream. Today we're going to be talking about a really interesting new feature contributed by an external contributor on GitHub, and that feature is a cache method on tables. And this method is interesting because it lets you store intermediate results using the native backend storage capabilities. So in the case of DuckDB, it'll be a temporary table in the database, and for other things, it'll also be a temporary table. Usually that's kind of what the implementation is. So let's dive right in and look at some examples. We're going to fire by Python. We're going to do our interactive import, and then we're going to pull out this IMDb table title principals, which is a database showing the principal people in a particular title. So let's see what that looks like. We've got tconst, which is an identifier for the title. Ordering, not entirely sure what that is. It might be time ordering, the order in which they did the things. Um, nconst, which is the identifier for the name of the person. And then category, like what job category they had, the specific job they had, and then what characters they played um, in the title. So let's say we wanted to find all the principal directors in this data set, and then do some other things with it. The first thing we might want to see is like, well, how selective is the category filter we have here? And the way you can see that's pretty straightforward. We can say t.count, count only the rows that have category director, and then divide that by the total count, which gives you basically the percentage of rows for which uh, uh, the job category is director. So let's see what that looks like. So it's 11.5%, give or take. Let's look at the total number of rows, because if we only have a few rows, it's like not a big deal. We probably don't need to like worry about storing anything in an intermediate table. So we've got about 55 million rows here, give or take. And if we're going to be kind of operating on a subset of columns and doing aggregations, and it's maybe not worth it. But here we actually want to get the whole table back. And so if you have a selective filter, cache can be really useful there. So let's look at what the cost of executing the whole, of filtering out only directors and returning the whole table. We'll use the time magic, and we'll just assign that to the variable df so that it doesn't print to the console, and we'll see how long that takes. So here I'm calling execute, which will return a pandas data frame. You can also call to underscore pi arrow or to underscore pi arrow batches and get back different kinds of things, which is pretty nice. So that took about 9 seconds, um, which is like not, we're kind of getting out of the bounds of interactive speed here, or we're pushing into like more, higher latency territory. With cache, what you can do is actually just incur that overhead once. Let's say, and the way you do that is you call this cache method, and then you can kind of transparently use it after that. You can chain, you can method calls, you can assign it to a variable, you can kind of just go about the rest of your analysis. And what happens in the background is that Ibis is storing basically a reference to the cached expression for the lifetime of your session. And here in a bit, I'll show how to clean that up if you want more control over the lifetime of that temp table. You can use a context manager. I'll show that behavior here in a bit. So we're going to incur the overhead one more time for the cache. But let's just assign that to a variable. We'll call it CT for cache table. You don't have to, again, you don't have to assign it to a variable. You can always keep chaining your methods and kind of using the flexible composability that Ibis provides, but you don't have to. So that was actually pretty fast. There's probably some DuckDB is probably retaining some of the buffers from the previous computation. And we can see, okay, we've only got directors. And um, now I can do things like, okay, show me, let's do what we were going to do originally, which was show the not null job columns. Sorry, job.notNull. And we've got a bunch of co-directors. Let's say we could do c.job.valueCounts. This is all pretty snappy now, right? Because we cached that table. And what's really cool is if I go back and just sort of like use the original expression I had, sorry, which was ct this, like if I just repeat this expression and then write, job, cache job, let's see, job dot value counts. It'll be similarly snappy because the back end is aware of the expressions that have been cached. And so it sort of has a global view of what's happening in your session. So we got our nice value counts at job. It looks like there's basically a bunch of directors that don't have specific job titles, which kind of makes sense. That may or may not be kind of part of the metadata when the piece is filmed. So I said I was going to talk about a context manager. Let's look at that. Let's use a different category. Let's use actor. Let's say actor and actress. It's that, and then we'll close that. Cool. We'll cache that. And so the way you use this is you say with.cache, and you say, the target of the context manager is, let's say, acting. And now acting will be cached. But when the context manager exits, acting will no longer be stored as a temporary table in the database. So in that way, you can kind of maintain some cleanliness if you're working on a system where you don't necessarily want to kind of be putting these additional tables around everywhere. That said, these are using the create temporary table for most of the backends that support them, which basically means that when your session ends, that itself kind of depends on the database you're using, but when your session ends, the database itself will clean up the temp tables. So this gives you more control, more immediate control, but you can also feel comfortable that you're not going to leave your database in sort of a state where you have all these random looking temporary tables around, because we use the mechanisms built into the database. Okay, so we've got acting, and let's again say job value counts, and then we'll execute that, and then look at it as a pandas data frame. Now this wasn't particularly useful, but but if you had multiple computations going on in there, and multiple sort of more expensive things coming off of acting, then you might you'd benefit from that. Let's look at pandas. Right, so this is not a particularly interesting computation. Like most actors, or it looks like all the actors and actresses have no specific job, which again kind of makes sense. Actor and actress, that's their job. Okay, so this has been caching using the cache method in Ibis, and hope you like it. Please get involved. Go to ibis-project.org. You can find us on GitHub at github.com, ibis-project/ibis. I'm Philip Cloud, and I will see you next time.